Its engine has fallen silent, its journey seemingly over. But this is not an end. It is a transformation. The world's largest source of recycled steel flows not from deep within the earth, but from the automotive recycling industry. Known as the car's second gateway, this process sends a massive stream of metal back into the global market each year. In the United States alone, over 12 million vehicles are dismantled annually, turning vast scrap yards into the most efficient steel mines ever conceived. Each car, once thought to have reached the end of its life, embarks on a new and vital journey. From here, its core elements are reborn, forged into the raw foundation for construction, industry, and even the next generation of automobiles that will one day travel our roads. It begins as a $48,000 investment, a machine of freedom and status. But after a decade of service, what is its final worth once it enters the crucible of recycling? The answer lies within a $60 billion global industry, a sprawling network where millions of vehicles are methodically dismantled, their forms crushed, and their essence reborn as fundamental raw materials. This vast operation sustains hundreds of thousands of workers, slashes the immense costs tied to smelting new metals, and dramatically lessens our footprint on the natural world. If we think of iron ore as a finite resource drawn from the earth, then these retired vehicles represent something else entirely, a limitless, man-made mine. Every single cycle of recovery conserves up to 74% of the energy that would otherwise be consumed in mining virgin ore from the ground. On average, a remarkable 75% of a car's total weight is reclaimed. This includes everything from its steel skeleton and aluminum components to its glass windows and plastic trim. The result is a staggering flow of hundreds of millions of tons of material resurrected each year to continue its journey in the framework of buildings, the design of everyday products, and even within the chassis of the next generation of automobiles. For millions of vehicles, the end of the road is only the beginning of a new cycle. This journey starts when a car, having reached the end of its life, is delivered to the intake area of a sprawling recycling plant. Here, a meticulous cataloging process begins. Technicians document the vehicle identification number, engine number, and year of manufacture, while assessing its overall condition and reviewing all related paperwork. Each car is then photographed, affixed with a tracking code, and its complete data set is uploaded into a digital management system. This digital fingerprint allows the entire process to be monitored and provides the basis for assessing the vehicle's remaining value. An inspection then determines which components can be given a second life. Engines, transmissions, electronics, and interior parts are all scrutinized. Usable components are carefully separated and supplied to the multi-billion-dollar market for used auto parts. Vehicles that are too heavily damaged or worn, however, are directed straight to the dismantling line for material recovery. Once this triage is complete, the cars are organized in lots across the yard, lined up in a clear, systematic order to enter the processing line. It's a scale of operation few realize, as in the United States, more than 95% of end-of-life vehicles pass through this system. This makes the automobile the most recycled consumer product in the world, ensuring every car maximizes its recoverable value and contributes back to the economy. Once a symbol of motion, it now stands perfectly still, awaiting its final transformation. With all vital fluids drained to secure the line against contamination, the car enters a new phase, the systematic dismantling of its major components. The process begins with the wheels, their sheer bulk and straightforward processing, making them the first to go. Old tires represent one of the most stubborn forms of industrial waste, taking decades to decompose in a landfill. Instead, most are shredded into fine rubber granules, finding new life in asphalt roads and soft playground surfaces. Others are repurposed as an alternative fuel for industrial furnaces, while their steel and aluminum rims are sent directly to smelters for recycling. From there, specialized equipment cuts through the seals of the windshields and window glass. This is laminated safety glass, fortified with a plastic inner layer that prevents it from shattering on impact. The recycling process recovers not just the glass itself, but also this valuable polymer, which is then reused in soundproofing materials and industrial coatings. Next, the doors are unbolted. These seemingly simple panels are actually complex assemblies, combining steel or aluminum frames with a host of internal parts. The metal frames are cut away for remelting, while the electric motors for windows, locking systems, and dense wiring looms are carefully stripped to recover copper, plastics, and magnets. Inside the cabin, the careful work of stripping the interior begins, with seats, dashboards, and carpets all removed and sorted. Miles of wiring are pulled out to retrieve their precious copper core, while plastics and fabrics are shredded and repurposed into entirely new materials. Finally, the engine and transmission, the heaviest and most valuable assemblies, are lifted from the chassis. Some are refurbished for resale, while others are broken down to extract aluminum, steel, copper, and even the precious metals hidden inside catalytic converters. This methodical sequence maximizes the value of every part, ensuring the empty frame is ready for the next stage. But before the crusher can do its work, the vehicle's frame still carries a mix of unwanted materials, from bent exhaust pipes and large plastic panels to tangled wiring. To deal with them, the shell is moved to a rough processing area where massive mechanical arms fitted with hydraulic shears take over. With tens of tons of clamping force, the steel jaws rip off any remaining doors, yank out entire exhaust systems, or crush radiators in seconds. Plastics, foam padding, and other materials that cannot be smelted are torn away and discarded on the spot. This brutal but efficient step acts as a coarse filter for the entire line, eliminating anything that could ignite, contaminate the final metal, or damage the crusher itself. After only a few minutes in the grip of the shear, the vehicle's structure is reduced to a clean shell of steel and aluminum, ready for compaction with maximum safety and efficiency. It once carried lives down open roads. Now a hollow steel skeleton faces the unyielding force of the press, its journey about to end in an instant of violent compression. The vehicle's bare frame is sent into the jaws of a massive hydraulic machine where compaction is achieved with maximum efficiency and safety. Under crushing forces between 150 and 200 tons, a structure more than 4 meters long is condensed into a compact block of metal, its volume reduced to just a tenth of the original. Depending on the technology, this process is handled by different machines, each designed with a specific purpose. With a car baler, the frame is compressed into a dense, cube-shaped steel bale. These high-density blocks are remarkably easy to stack, store, and transport, with modern industrial balers handling 25 to 40 cars per hour. This makes them ideal for large-scale facilities that need efficient storage before shredding. The car flattener, on the other hand, is popular in mid-sized or smaller scrapyards. It compresses vehicles into flat sheets only a few dozen centimeters thick, offering advantages in speed, lower energy use, and reduced investment costs. The trade-off is that flattened cars are less dense than bales, meaning the later shredding stage consumes more energy. Meanwhile, the shear baler both compresses and slices, cutting the vehicle into short, manageable sections. Although its throughput is lower, it offers a direct path to shredders, or in some cases, directly into smelters, skipping the baling step altogether. Each method is a different philosophy of deconstruction, but all share the same goal: transforming a bulky car into uniform metal, ready for its next life. Once the car's frame has been compacted, the dense steel bales are fed into a high-capacity shredder, the mechanical heart of the entire line. Inside its chamber, massive steel shafts armed with interlocking teeth rotate in opposite directions, tearing the compressed block apart within seconds. The thunderous clash of metal fills the air, and in an instant, a car that once occupied a full parking space is reduced to uniform fragments of scrap. The throughput is staggering. A modern industrial shredder can process 100 to 150 tons of steel per hour, which amounts to hundreds of vehicles each day. This sheer efficiency allows the auto recycling industry to operate at scale, transforming mountains of scrap into raw material ready for smelting. After shredding, the mix of metals and nonmetals is carried along a sorting line. Powerful magnets pull out carbon steel first, while eddy currents generate fields that deflect aluminum and copper to the side. Any remaining plastics, rubber, and fabric residues are discarded. The recovered steel is compressed into bundles for the furnace, while aluminum and copper are collected separately for other industries. From a single discarded car, The line takes less than an hour to recover pure, reusable metals, ready to re-enter the cycle of production. A storm of electricity is about to resurrect dead metal. From compacted, shredded, and sorted bales, what was once an old car frame is ready to re-enter the cycle of production. The journey toward rebirth begins as these blocks are fed into an electric arc furnace, a chamber where they will face a true inferno. Graphite electrodes unleash currents of tens of thousands of amps, igniting a blazing arc that resembles artificial lightning. Within minutes, temperatures soar beyond 1,600 degrees Celsius, turning the scrap steel red hot before it collapses into a stream of liquid metal. To purify this molten bath, lime and flux are added, drawing out impurities that form a layer of slag on the surface, while oxygen lances burn away any unwanted elements. Throughout this fiery refinement, sensors and spectrographic analysis provide continuous monitoring, ensuring the alloy composition meets exact specifications. A chaotic mass of old car parts has now become a glowing sea of pure molten steel, ready to be cast. This liquid metal cannot be left to cool in the furnace. It is immediately channeled through sealed troughs and into the continuous casting line. A blazing stream of liquid metal flows into water-cooled molds, solidifying within seconds to form a hardened outer shell. Inside, the steel core remains molten as it is carried forward by rollers, gradually cooling along the length of the line. From this process, long billets stretching tens of meters take shape, square billets for construction steel, and flat slabs destined for rolling into sheets or coils. Automated thermal saws then cut them into standard segments, each weighing several tons, before every billet is numbered, scanned, and logged into batches. The moment they leave the reheating furnace, glowing red steel billets surge into the hot rolling mill. Here, dozens of massive rollers continuously press, stretch, and bend them into new shapes. With every pass, the steel flattens and lengthens, evolving from a heavy, rough block into uniform sheets or coils, while high-speed cameras and laser sensors measure thickness and straightness with precision. This freshly rolled steel must now be cooled in a controlled manner. High-pressure spray nozzles envelop the surface in a white mist, rapidly lowering the temperature without causing cracks. Afterward, powerful fans blow along the length of the coils, allowing the steel to cool gradually and preserve its internal structure. Once the temperature is safe, each coil undergoes a final, rigorous inspection. Ultrasonic sensors scan for hidden fractures, high-resolution cameras examine every surface detail, and mechanical testers measure tensile strength. Only those that pass this intense scrutiny are stamped and stored. From fiery brilliance to stable strength, steel emerges ready to serve hundreds of modern industries. Its journey on the road is over, but its story is far from finished. The transformation from a seemingly useless car into a valuable resource begins with a careful deconstruction. Every part is methodically dismantled, while fuel and other fluids are drained away to ensure a safe process. Next, massive presses exert hundreds of tons of force, collapsing the empty frame before it meets the thunderous roar of the shredder. Once torn into fragments, the metals undergo a precise sorting process. Powerful magnets, eddy currents, and advanced sensors work in concert to separate each material with remarkable accuracy. From here, the purified metals enter the furnace, where intense heat melts them down to be reborn as new steel. This molten material is then hot-rolled, cooled, and inspected, emerging as a clean and durable product. This reborn steel is now ready to serve vital industries, finding its way into construction, heavy machinery, and even the frames of new automobiles. Each end-of-life vehicle, rather than being discarded, fuels a multi-billion-dollar industry that dramatically cuts energy consumption and eases the strain on natural resources. It stands as proof that recycling is not only an environmental solution, but also a hidden pillar of the modern economy.